The gas phase is different than the solid and liquid phases in the way that gas molecules have complete freedom to move around. This follows that a gas can be described as a substance whose particles move very fast in straight lines until they collide with the walls of the container or with each other and have empty space between them. Consequently, gases are compressible. They expand to fill their containers and mix with other gases evenly and have much lower densities than solids and liquids. In this chapter, the properties that emerge from this behavior will be studied. The properties that define the state of a gas are volume, temperature, pressure, and the amount measured in the number of moles. These properties are interrelated, meaning that changing one property will affect the others. These relationships are described by the gas laws and explained by the kinetic molecular theory. Volume of a gas is the space occupied by it. Since gases expand to fill their containers, volume of a gas can be found by measuring the volume of the container. If the volume of the container is given, that is equal to the volume of the gas. Temperature is the measure of the average kinetic energy of the gas molecules. The higher the temperature, the higher the kinetic energy. The kinetic molecular theory states that the average kinetic energy is equal to 3 over 2, the product of R and T. Here, R is a constant, 8.314 joules per mole per Kelvin, and temperature is in Kelvin. This relationship indicates that kinetic energy is dependent only on temperature and independent of the type of gas. This realization has important consequences, as discussed in more detail under the kinetic molecular theory. Pressure is a physical phenomenon defined as the force exerted per unit area. It is a measure of how concentrated force is. Subsequently, pressure can be changed by changing the applied force or the area that is applied to. When force increases, pressure also increases due to the direct relationship. The higher the force, the higher the pressure. On the other hand, pressure and area are inversely proportional. Decreasing the area results in an increased pressure. The smaller the area, the higher the pressure. For example, this is how a push pin can be pushed into a wall. The force applied is concentrated in a very small surface area at the tip of the pin, which creates a large pressure on the wall and penetrates it. Gas pressure is caused by the collisions of the gas molecules with the walls of the container. Gas molecules are in constant motion, and they constantly collide with the walls of the container. Each collision imparts a force, and the cumulative effect is observed as gas pressure. Recall that pressure is force applied per unit area. Therefore, any factor that changes force or area has an influence on gas pressure. One of those factors is temperature. Since temperature is the measure of the kinetic energy of the molecules, at a higher temperature, a stronger force is imparted. Therefore, the higher the temperature, the higher the pressure. Pressure is directly proportional to temperature. For example, when the Kelvin temperature of a gas is doubled, its pressure also doubles. Keep in mind that this proportionality cannot be made for the Celsius or Fahrenheit scales, as physical properties depend on the absolute temperature measured in Kelvin. The other factor that affects gas pressure is volume. Since volume is proportional to the area of the inner walls, the smaller the volume, the higher the pressure. Pressure and volume are inversely proportional. For example, When the volume of a gas is halved, its pressure doubles. The first documented measurement of pressure was made by Torricelli in 1643 using a mercury barometer. Torricelli filled a glass tube with mercury and inverted it into a dish of mercury. The mercury in the tube dropped to a certain height, creating a vacuum at the top of the tube. This proved that air exerts pressure on the surface of the mercury on the dish. The liquid mercury is in an equilibrium state, meaning that the downward pressure of mercury is balanced by the upward pressure exerted by the surrounding fluid caused by the atmospheric pressure. Since the height of the mercury column depends on the atmospheric pressure, it can be used to measure the atmospheric pressure. At sea level, the height of the mercury column is measured as 760 millimeters. Therefore, at sea level, atmospheric pressure is said to be 760 millimeters mercury. Due to historic reasons, this can also be called in the units of torrs, coming from the name Torricelli. The pressure at sea level is also known as 1 atmosphere pressure. The Torricelli experiment also meant that we live at the bottom of an ocean of air. And air has weight above us, creating pressure. Air is most concentrated on the surface on the Earth due to gravity. As you climb to higher altitudes, there is less air above you, and thus air pressure decreases. We say air gets thinner. In day-to-day applications, there are different devices to measure gas pressure. For example, barometers are used to measure the atmospheric pressure. Gauges are used to measure the pressure of a gas in a vessel. In more technical applications, where pressure needs to be recorded or monitored by a computer, pressure transducers are used that convert the measured pressure into an electrical signal. Blood pressure monitors measure blood pressure.